important to do this, because we've got a platform here, and this is an educational platform, and we want to make a difference in the world with that.
Well, thank you very much, Prem. It's been lovely to hear from you. Hopefully we'll hear from you again this time next year after another very successful year. We hope to see where you can lead the team next year.
Thank you very much.
Thank you.
We would now like to welcome to the stage someone who's been with us since the very start. Warwick Racing would not be possible without this individual. He is the CEO of WMG High Value Manufacturing Catapult, Dave Greenwood.
Thank you. So, good evening, everyone. Shortly, they're going to be taking the black cloths off these vehicles and we're all going to see something very impressive from a technical perspective. But actually, I'd like to say that you're looking in the wrong direction. The most impressive thing from a technical perspective that's in this room today are the engineers that are standing on that side of the room. And that's the reason that WMG gets involved in these projects and sponsoring them. The academic degrees that we teach here at Warwick are brilliant for teaching knowledge. They'll teach you the things you need to know in your next job. What they don't do, unfortunately, is teach you how to work in proper professional environment. And that's where you need to be able to work as a multidisciplinary team. You need to work to deadlines. You need project management, risk management. You need to manage budgets. You need to persuade people like me to give you money to do stuff. And that's what these projects do. And the reason that we're so keen on them is because it gives you that additional experience over and above what you would take from your degree. And I know from my life in industry before I moved to Warwick University, some of the best graduates that we employed were those who'd come through programs like Formula Student. So it's something that I'm personally a huge fan of. I probably spend more time than I ought to in my role coming down to the pits and seeing what's happening with this project and with the Moto project and the submarine and the rail project, search and rescue, all those other great things that are going on. They're hugely exciting. When we bring visitors around the university to explain what we do, we're running a business here which is, what, £140 million a year turnover? And the thing that attracts their attention, the thing that grabs them and helps them to understand what we do, which is to deliver the people and the technology that industry needs in the future, these student projects are the ones that they latch onto most quickly and most easily. So first of all, thank you to all of you also for putting up with the fact that I keep arriving with people and pushing you away from cars and motorcycles to explain the great stuff that you're doing. But you're also brilliant ambassadors for the university. So yes, please, enjoy the vehicles, enjoy focusing on the technology, but just remember that the real achievement is you guys. Well done.
Reset right. That's it.
Thank you very much, Dave. The success the team has had over the last decade wouldn't have been possible without your great support. So we hope that will continue.
It's now time for the first of our main events, the unveiling of our first generation autonomous vehicle, WRAI.
I think we can all agree that it looks pretty good. It looks like it's going to be nice and fast when we get to comp. I would now like to introduce two of the lead engineers on the AI team. So we have Mabuba Durajaye, who's the chief AI engineer, and Ilinka Tribleka, who is the chief AI software engineer. And we'd like them to share some of the experiences they've had on the car so far.
Mabuba, tell us about how the concept of the car came about.
Essentially, we went to competition last year. And up until that point, we had just been doing a lot of research into potentially competing in the autonomous competition at Formula Student. And then actually seeing those cars at competition last year, we decided to take on the challenge. It was kind of a motivation to just kind of start implementing and stop researching.
When converting an IC car to an EV autonomous car, Mabuba, can you kind of talk us through some of the things you had to do to make this possible?
The main thing was a lot of working with the space we already have. So we placed a lot of focus on keeping the costs down and really using what was already there, a lot of recycling, a lot of reusing components from other projects or just things from old cars. And then, of course, we had to implement a lot of drive-by-wire systems like our brake-by-wire and our steer-by-wire, and also our new battery packs and an entire EV powertrain.
Ilinka, there are some sensors on the car. Can you talk us through how they interact with the car, but also the surroundings?
Yes, of course. Thank you for the question, Will. So I would say that the sensors are basically the heart of an autonomous car. To be able to drive itself down the road, a car needs to be able to see its surroundings, identify objects and situations in its surroundings, and also make real-time decisions based on its surroundings. So that's the job of the sensors. A lot of that is it also relies on the quality and accuracy of the sensors. Right now on the car we have a camera and an inertial measurement unit, but we are also looking into getting a LiDAR for future developments. We're still looking for a sponsor. Yeah, so basically how it works is, first of all, the sensors need to work. They need to perceive their surroundings. Then they send that data back into the autonomous systems, which are basically our perception, path planning, localization, and mapping algorithms. And then those autonomous systems send that data back into the car, into the mechanics that do the steering and the braking. Yeah, this is basically how the sensors interact with the car, its surroundings, and the mechanics, and makes it go down the road. Yeah.
Well, thank you for that both. That's very interesting. We can't wait to see this go around Silverstone in a few weeks, actually. So it's getting very close. So we would love to see the AI journey continue over the next few years. So thank you both. We hope to see it grow.
Thank you, guys. It's almost time to reveal WRE2, but before we do, we would like to share this short video of our journey with you. Please excuse while we have the technical setup. I'd just like to say this is the first time that any of the team have seen the car, so we're all very impressed by AI. The AI team did an excellent job. Well done, guys. It's beautiful. So here you can see some welding on the car. So this is the formation of the chassis on the car. You've got to start with the frame. So that was helped by the technicians. Very high-tech stuff. This was how it looked a few months ago. And yeah, there's some electronics going on, so that's lock wiring, there's prem. But as you can see, this is a continuous process. There's an awful lot going on here. Marcel and Harry, Sachin, that's Jan, our business manager. Behind you saw our whiteboards that had all our ideas on, our jobs, make sure we get it done in time. That's the HV cable. So there's so many different parts that go into this. And really, we're very lucky to have the team that we do, where everyone's willing to get involved in anything, really. Outside of their team, they'll just get stuck in. If there's a job to do, we'll make sure it happens, which is why we're very happy with our cars this year. There's the brackets for the wheels. Yeah. There's the wishbones going in for the suspension. It really is unbelievable until you start working on it how many different parts of the car there are, but it is astounding. Everyone lowering the car onto the floor because it is extremely heavy. It's about 400 kilos. There's me rubbing my hands because the car looks so good. And Dave's testing the suspension, make sure it works. So those are our nice Warwick green wheels, specially made.
Here's Prem fitting the chain. I think this video in whole shows just how much of a team effort this is. It may only be a few faces that we show, but to get this car here together in one piece today has taken so many people. It's such a long effort, so I think this video just summarizes how much blood, sweat, at times tears has gone into actually building this car.
So yeah, just a short snippet. We just thought we'd show you the behind the scenes because there's a lot of work that goes into it. Yeah.
So now is the moment we've all been waiting for.
The culmination of a year of hard work and determination.
Our second generation electric vehicle,
WRE2. There she is, absolutely beautiful. Now that you've had the chance to admire the car, we'd like to invite on some of the people who helped make this possible. So could we have back Team Principal Prem, as well as Chief Electrical Engineer Sachin Barge, Chief Battery Engineer Boaz Vipulananthan, and Chief Control Systems Engineer Marcel Afonya. Hi guys, you okay?
Okay, so Prem, as we've seen from the video that was wonderfully narrated by Will, the team has been working tirelessly to put this car together. How much of a challenge has it been this year to actually kind of get the car to this point ready for comp?
Oh yeah, it's been a huge challenge, especially if you look at where we were last year and how far we've come now. I'm really proud of the team. I think we're in a good way. Definitely, we're pushing on now. We've got 3 weeks left, so hopefully when we go to Silverstone and we compete, we've got to get through scrutineering first. But like Dave was saying earlier, the competition doesn't wait for you. This is exactly like industry will be, and we're very happy. And we're hopefully going to make everybody proud in a few weeks. Thank you very much.
I'm sure we will. Thank you, Prem. Sachin, some people may be wondering how an electric vehicle actually operates because they may be used to internal combustion. So could you explain how it works?
Yep, so essentially there's a tractive system network on the car. So our accumulators actually provide in excess of 400 volts to the entire tractive system. Then that goes to the inverters, and that converts the DC into three-phase AC for the three-phase motors, and then that produces a torque for the wheels. And then we also have the low-voltage systems, which are all the safety networks.
And what are the main problems that come from trying to make a electric vehicle?
I think you'd be surprised that actually, for a Formula student car anyway, the safety requirements actually go beyond a Formula One car. So there's so many, low voltage circuits, so many, safety checks that we have to go through before we can put that 400 volts into the car. And, it's all for safety at the end of the day.
Well, some of the most interesting parts on this car are part of the powertrain, specifically the accumulators. Boas, can you tell us a bit about the accumulators that we'll have on this car come competition?
Yeah, the accumulators can be tricky. The batteries for an EV, but for WRE2 from the ground up, it's been designed with both performance and safety in mind. And it's quite common in motorsport as well as in industry to outsource the design and production of batteries. But for us, we've designed it by students and manufactured it by students as well.
Very impressive. And Marcel, Warwick Racing is constantly pushing the boundaries of what's possible in motorsport. So in terms of converting the power into pace on the track, the software plays a key role. Could you be able to tell us a bit more about that?
Yeah, of course. So this year we put a really big focus on our software, integrating traction control, torque vectoring, regenerative braking and launch control, which also affects traction control. So hopefully on Silverstone this year we'll be tearing through the corners, controlling each motor individually to really give us that boost. We're controlling it using our own ECU, so instead of an off-the-shelf device, we've actually created our own PCB using a TNT. which is basically like a more powerful Arduino. So yeah, we're really looking forward to it, and we've learned a lot, and we've done a lot of simulations. We've really gone into the IPG car maker software, which is very powerful software for simulating and verifying stuff. So it's a very, I think we've done really well this year in terms compared to other years, because we've really gone deep with the software.
Well, thank you very much to our engineers who, without them, this car wouldn't be possible. So, thank you.
Well, another group of people we'd really like to thank are the supervisors of our project. So we have Dave Cooper, Malcolm Swain, and James Meredith. So I think without these guys, these cars wouldn't be possible. I think they're working on the cars more than most of us. I mean, they're in there before we are. They're leaving half the time after us. I mean, they've got families to go back to, but yeah, they still come and help us when we're being a bit of a pain. So I think without them, I don't know how we'd manage to get anything to competition. So just again, thank you to them, and not just them, but also the technicians throughout WMG and all the companies that actually help us make some of the parts on the car, like Aquajet.
All these people, especially our supervisors, really mean a lot to us because all their work gets ignored. People don't realize the amount that they put in teaching us the skills so that we can build something like this. So they really are, they're all the man. So thank you very much. We really appreciate it.
Yeah, thank you again, guys. Okay, so we would like to thank everyone here for sharing this experience with us. I mean, we've not seen the liveries before tonight, so I think we can all agree they look great. Can't wait to see these guys out testing and on the track. But yeah, hopefully we'll get them to Silverstone next week, in a few weeks' time, as fast as possible.
And we'd like to say a special thank you to Krishan Vasani for setting up the livery. He's been behind the scenes, he's done all sorts, and he really does deserve it. So thank you, Krishan.
We'd also like to thank Navraj Baines, who's our project manager. He's done a massive job helping organise this event, as well as all of the deadlines we've had in recent weeks, which have been very stressful, but he's done a massive part in that as well. So thank you, Navraj.
This would not have been possible without the support of all our stakeholders and our supporters. So we really appreciate it, and especially our team members, who have done an absolutely amazing job. So we'd like to invite our team to come onto the stage and share this moment with us. So yeah, come on guys, come on, everyone. Scoots down if you, yeah, everyone come on, crowds, whatever. Come on, guys. Warwick Racing 2022 to 2023. Thank you very much, everybody. Please come and have a look at the cars and tell us what you think.
have the 3D printer. They even have like a model jet printer and they have a laser printer. So they use a combination of all of them.
What's water jet printer?
So in engineering,
could do a VD2 photocopies in 3 of us. Well, short of Canberra, it's the only contributing campus, so it's 3/4. It's pretty good. It's me, I walked in for nothing. It looked like I just walked in for nothing. Because I had something that LB and S like six. That's why I've been S super fuckers.
It's close enough.
We've been pushing hard. It would be nice not to.
I think that's the thing.
That would be good. Because the thing is, like, short of like bug fixes, the cars are so close to yeah, same with me. I'll be in next week to finish my job.
I'll be in fantastic.
Then I'll just float. Not worried. I don't think we have anything to worry about.
You can't see the car.
You can expect that. No, as they walk around the front,
What was the slow battery? And if you were that was quite nice.